Welcome to Educator.com. Today we're going to be covering addition and subtraction techniques. You're going to be using these techniques frequently throughout algebra in order to solve an equation. The big thing is knowing what you're allowed to do and what you're not allowed to do when you're manipulating an equation. The first technique is the addition principle. And this states that if the same number is added to both sides of an equation, the resulting equation is true. So to illustrate this, let's look at an extremely simple equation, x equals y. Now, if I add the same number to both sides, let's say I add 4 to both sides. That equation is still true. Let's look back at the original equation and instead substitute in a number. Let's let x equal 2. So my original equation was x equals y. So if x equals 2, then y equals 2 as well. Now, if I add 4 to both sides, I'm going to have 4 plus 2 equals 2 plus 4. I add that up and I get 6 equals 6. That equation is also true. And that's the logic that underlies the addition principle. As long as I add the same number to both sides, the equation will still be true. But what's important is you need to make sure that you add to both sides and not just one side. Okay, this works the same for subtraction. Same idea. If I have an equation x equals y, and then I subtract, say, 2 from both sides, the equation is still true. You could again try it with numbers. Assign x a value of 4. So in my original equation, then I would have x equals 4, so y also has to equal 4. If I subtract 2 from both sides, 4 minus 2 equals 4 minus 2, I can easily see that the equation is still true. The strategy is to be used in algebra is that you're going to use these principles, the addition and subtraction principles, to isolate the variable. When we say isolate a variable, what we mean is that you want to get it alone on one side of the equation. For example, if you have an equation 2x plus 3 equals x plus 6, and you want to solve the equation, what you need to do is get all the x's on one side, all the same variable on one side, and everything else on the other side. So if I have 2x plus 3 equals x plus 6, and I say that I want to isolate x, or isolate the variable, I need to get the x's on the left and all of these other numbers on the right. And what we're going to do now is work with some examples and apply the addition and subtraction principles. Starting with a simple equation. 32 plus z equals negative 17. I want to isolate z. Looking at this, on the left side, in addition to z, I have 32. And the way I'm going to get rid of the 32 is to move it to the right side. And I go about that by doing the opposite. So whatever I'm trying to remove here, I'm trying to remove 32. So I need to do the opposite, and it's a positive 32. So if I subtract 32, I can get rid of it from the left side and put it on the right side. Okay, so you want to do the opposite operation. (32) plus z. Subtract 32 equals minus 17. And it is absolutely crucial to also subtract 32 from the other side, because if you don't, the equation will no longer be true. See, what happens on the left is the 32's cancel out. So I have 32 minus 32 is 0, which gave me exactly what I wanted, z alone. And that is equal to minus 17 minus 32, which is negative 49. So in order to isolate the variable, I looked at what I had next to the variable, which was a 32, and then I did the opposite operation, which, since this is a positive 32, I'm going to subtract 32. When you look at this next example, it appears more complicated because it contains a fraction. However, you just do the same thing. Solve w minus 1/4 equals 3/4. By solve, we want to isolate the w on the left side of the equation. This time, the value with the variable is negative. So I want to do the opposite operation. W minus 1/4. Therefore, I'm going to add 1/4 to both sides. W minus 1/4 plus 1/4 equals 3/4 plus 1/4. And notice I did this to both sides. Again, by doing the opposite operation, I end up with a 0 instead of the 1/4. So w minus 1/4 plus 1/4, I'm just left with w, equals 3/4 plus 1/4. Since those have the same denominator, I add them together and I get 4/4, which can be further simplified to w equals 1. Again, if I look back at the original equation, I saw that I had w minus 1/4, and since I wanted to isolate the w, I'm going to add 1/4 to turn this into a 0, and then also add 1/4 to the other side so that the equation stays balanced, stays equal. In this example, we have a sentence, and we already discussed how to translate a sentence into an equation. 27 is 4 more than a number. Find the number. So we discussed turning this into an equation, and then now they're also asking us to solve it. So first, I need to translate the equation, and then I need to solve. Just as we've always done, we look at this and assign a variable. So I have 27 is 4 more than a number, and I'm going to let x equal this number. So I assigned a variable. The next thing to do is find out where the equal sign is. 27 is 4 more than a number. Is. That splits the equation into the left and right halves. Okay, now I'm ready to translate. My left half first. Very easy to translate. 27 is equals. So that half was very simple to translate. Now the right half. 4 more than a number. 4 more than. I need to turn that into a mathematical operation, which is adding. And it's 4 more than a number. Well, I already said that. I'm going to call my number x. Find the number. Before I find the number, I always go back and check to make sure I translated correctly, because if I translated incorrectly, I'm going to end up with the wrong answer. So 27, and I have a 27 here, is, so equals 4 more than 4 plus a number, so x. Now find the number. In order to find the number, we're going to have to apply the addition or subtraction principle. And when I look, what I have with the x is a positive 4. So I need to do the opposite operation. In this case, I'm going to need to subtract 4 from both sides. 27 minus 4 equals 4 plus x minus 4. 27 minus 4 is 23 equals, the 4's cancel out, leaving me with x. 23 equals x is the answer, but by convention, we usually write the variable on the left side. So I'm just going to switch this around so that it looks a little nicer, but it's the same thing. So the answer to this problem is x equals 23. After translating the sentence into an equation, I ended up with 27 equals 4 plus x. And then to isolate the variable, to isolate the x, I subtracted 4 from both sides, giving me 23 equals x, which is the same as x equals 23. Here's another example in which we're given a sentence, but we also have some numbers, and it looks a little messy because we have both decimals and mixed numbers. So let's read through this. The sum of 20.7 and 2 3/4 and a number is equal to 42 2/3. What is the number? Okay, and looking at this, I see a number, and that tells me I need a variable. So I'm going to let x equal a number. I've assigned a variable to my unknown. The next thing I'm going to do is look for the equal sign. The sum of 20.7 and 2 3/4 and a number is equal to. They made it really easy for me this time by just saying is equal to. So I know that's where my equal sign is. Looking at the left half of the equation. The sum of. That's telling me that I need to add. And what I need to add is 20.7 and 2 3/4 and a number, and I said I'm going to call the number x, is equal to. Okay, so it's equal to 42 2/3. Before I do anything else with these, I need to put the numbers in a form that is the same and a form that's easy to work with. So I'm going to switch these all into decimal form. 20.7 plus 2.75 plus x equals 42.67. I'm rounding to the nearest hundredths here, so I'm going to call 2/3 42.67. Before I go on, I'm going to add the two numerical values on the left to further simplify it before I start trying to isolate the variable. And if I add 20.7 and 2.75, I'll come up with 23.45. Plus x equals 42.67. Okay, now I'm finally ready to start isolating the variable. Same as always, do the opposite operation. I have 23.45. So in order to isolate x, I need to subtract that amount, 23.45, from both sides. Okay, the 23.45s cancel out on the left, so I have x, and if I subtract 42.67 minus 23.45, it actually comes out to x equals 19.22. Okay? Looking back, I started out with a sentence. And not only was it a sentence, but it was a sentence that had numbers in two different forms. So after I translated it into an equation, I put all the numbers in decimal form. So that was the second step. Put numbers in decimal form. I simplified the equation by adding the two numerical values on the left, and then I finally isolated the variable by subtracting 23.45 from both sides. That concludes this lesson. Thanks for visiting educator.com.